Alright, let's introduce second order circuits and talk about initial and final values in this lecture. So in the previous chapter we talked about first order circuits, and that was mainly looking at RC circuits in parallel and series, as well as RL circuits in parallel and series, as well as we discussed source-free RC circuits and source-free RL circuits. So essentially what we're going to do is we're going to expand on that and go into second order circuits, and that is when you have in this case an RLC circuit. So you have a resistor, an inductor, and a capacitor instead of just a resistor and a capacitor, or a resistor and a conductor. So let's go ahead and give a definition, and then I'll give you some more specific examples. Okay. So a second order circuit is going to be characterized by a second order differential equation, and it's going to consist of resistors and the equivalent of two energy storage elements, and the equivalent of two energy storage elements. Okay. Alright, so I mean we have the capacitor and the inductor, which we've been using for the last couple of lectures, but in this case I want to show you that if you look here on the left, we have a resistor and we have a storage element, inductor, storage element, capacitor. You have a resistor, you have a storage element, capacitor, and you got the inductor. Essentially what we're seeing here in these first two figures, in figure A, is we have a series RLC circuit, and we have here a parallel RLC circuit, and both of these are second order. But in addition to that, you can actually look at the last two figures, C and D, where in this case you have again resistors and you have a storage element, and this is inductor, and then you have a resistor and you have a capacitor and a capacitor. In this case we have a second order RL circuit, and then you have a second order RC circuit. Okay, so we'll talk about that in this chapter as well. So you can have first order circuits for RC and RL, and you could also have second order circuits in RC and RL. Okay, and of course this also expands to operational op amps, but we're not going to discuss that in this chapter. A couple other things we want to discuss, or for the sake of keeping things more narrow in the scope, we'll only be talking about DC sources in this chapter. In future chapters we'll talk about AC sources. So for now we're going to discuss DC sources, and leave the AC sources for future chapters. Okay. So this is a quick overview of what second order circuits will be like, and then a couple things we need to know about when we're dealing with second order circuits is the most difficult part, or maybe the part where most of us may have issues with, is finding initial and final values. So finding the initial and final values in a circuit. Okay, so in addition to finding V at time 0 and current at time 0, and we've used V for the capacitance voltage, and we've used I for the inductance current, and we'll continue to do that in this chapter. But in addition to that, we want to also look at the derivative of the voltage and derivative of the current. Okay, so we want to look at the initial and final values of V the voltage at 0, the current at time 0. We'll look at dV of 0 over dt. We want to figure out what di of 0 over dt is. We want to look at the current at infinity and the voltage at infinity. Okay, and then for the sake of simplicity, when we talk about voltage, we're going to be looking at the capacitor voltage, and when we talk about current, we're going to be looking at the inductor current. Okay. Okay, so we want to be able to figure out what these guys are. So let's just go back and do a quick summary. So if we're going to look at the capacitor, we have our V of 0 plus is going to equal to our V of 0 minus. And the reason that's the case is because the capacitor voltage is always continuous. And then we go I0 plus is going to equal to I0 minus. And again, the current is always continuous, where t equals 0 minus is the time just before the switching event. So time just before switching event. Okay, and then t equals 0, plus is time just after. Okay, time just after switching event. Okay, and that switching event is going to take, which happens at t equals 0. Okay, so finding the initial conditions, we want to look at those variables that cannot change abruptly. So we want to look at the capacitor voltage, and we want to look at the current across the conductor. So we want to look at the voltage across the capacitor. We want to look at the current across the inductor. Okay, so these are things we want to discuss in this upcoming chapter. But just a quick introduction. The main difference between first order circuits and second order circuits is that with the second order circuit, you have an additional storage element. So in this case, we have an RL and C, whether it's in series or whether it's in parallel. And in other cases, you might just have an R and L, where we cannot get an equivalent RL circuit, so it's actually going to be a second order rather than a first order. And then you can have an example where you have RC circuits where it's no longer first order circuit, second order, and we'll discuss those in upcoming examples.